Alright, this is the pH concept, section 20.3. This is the first of two parts. Here's our objectives. Be able to calculate the hydrogen ion concentration and the hydroxide ion concentration for a solution of acid or base. Understand what this word autoionization means, and then state the hydrogen, hydroxide, and Kw values for the autoionization of water. So this is the first part of that set. First of all, when we're talking about an acid, we get the hydrogen ion, and when that dissolves in water, it's usually associated closely. We've got an H plus, and it usually meets a water molecule, and it's attracted to it, and so you get this hydronium ion, this H3O plus, when they're in. And usually we write it as H3O plus, like that. That is, like I said, known as the hydronium ion. Although a lot of times it's still written as H plus. So just be aware that either one of those, they mean the same thing. So for instance, I could write this. HCl dissociates into hydrogen ions and chloride ions. I could write it this way. Probably be a little more precise about what it is, a little more accurate. But either one of them is acceptable. So even if we have pure H2O, some of that breaks up into hydrogens and hydroxides. So some of this just breaks apart randomly. Not very much, but that process is known as autoionization. And it says it's when the same reactant acts as both an acid and a base. Basically what we're saying is water becomes an acid, hydrogen, and hydroxide. You could write it this way. I noticed that this should be a 3, H3O plus. We could write it like that, or just write it like this. And this is probably more common to see it something like that. All right. This is something new, and we've kind of skipped some of this, so we're going to start talking about something called equilibrium constants. And when they're talking about an equilibrium constant, they're talking about like a measurement of how much something ionizes, how much it's going to dissolve, or the reaction's going to take place. So we're talking about Kw is known as the equilibrium constant for water, and it is measured by taking the concentration of the hydrogen ion, this one, times the concentration of the hydroxide ion. In pure water, when we're talking about pure distilled water, this is the amount that ionizes and becomes hydrogen. And of course, whatever becomes hydrogen, the equal amount has to become hydroxide, because together that was an H2O, and so it divides into those two things. 1 times 10 to the 7th. That's a very, very, very small amount, but that's the amount of water molecules that will dissociate, that will change into those hydrogens and hydroxide ions just randomly. That's that autoionization again. Okay? So, there are equilibrium constants for all kinds of things. Water is one of the most important ones, so it's a special one called Kw, known as the ion product for water. So just be aware that when we're talking about Kw, we're talking about the concentration of that ionizes. So that would be like our hydroxide ion times the hydrogen ion. Okay, so this is our formula that we're going to get. And when you see things in brackets, they're talking about the concentration of them. So that means what is the concentration of hydrogen ion? And of course, in pure water, the hydrogen ion concentration, I told you, is 1 times 10 to the negative 7th. Hydroxide has to be the same, because in pure water, every time you get one of these, you get one of those. So Kw would be 1 times 10 to the negative 7th times 1 times 10 to the negative 7th, which is 1 times 10 to the negative 14th. So the constant, the equilibrium constant for water, is 1 times 10 to the negative 14th. Now that's going to be an important thing for you to remember, because it's going to become important when we finally get to talking about pHs and things like that. But this allows us to define an acid and a base a little bit more than what we have done so far. So for instance, what we could say is if these two things are equivalent, if the hydronium ion concentration, or remember this could still just be the H plus depending on how we want to write it, if these two are equal, then we have a neutral solution. That's water. Okay, we said these are the same. Hydrogen, hydroxide, same thing. However, there's more of the hydrogen or hydronium ion. You have more H pluses or H3O pluses, you have an acid. If you have more hydroxides, then you have a base. So anytime that you can figure out how much of this and how much of those there are, if there's more of this one, you have an acid. If there's more hydroxides, you have a base. That's the way it always works. And that's how we can calculate a lot of this stuff. So a lot of times what we'll do is we always know what Kw is. That's always 1 times 10 to the negative 14th. And sometimes we know what one of these is. We can calculate the other one. All right. So if our acid concentration, H3O plus, is greater than 1 times 10 to the negative 7th, and the hydroxide is less than 1 times 10 to the negative 7, 1 times 10 to the negative 7th, then you have an acid. On the other hand, for a base, you have a higher hydroxide ion. So really what I'm doing, I'm just stating the same thing that we had previously in just a little bit different way. So anytime that the hydroxide ion is greater than 1 times 10 to the negative 7th, or whichever way you want to look at it, the hydronium ion is less than 1 times 10 to the negative 7th, you have the base. If hydroxide is greater and hydroxide is less, if hydronium is greater and hydroxide is less, you have an acid. So this allows us to do some calculations. So let's take a look at this. It says calculate the hydroxide ion concentration if we knew that the hydrogen ion concentration is 1 times 10 to the negative 4th. Okay, so we know this one. We know Kw, 1 times 10 to the negative 14th. We know that the hydrogen is 1 times 10 to the negative 4th, and we don't know hydroxide. So we need to solve for that. So we would divide both sides by 1 times 10 to the negative 4th. Okay. So when we do that, this is going to cancel. And if you recall, when you have exponents like this, and as long as these are both ones out front, the exponents, when you are dividing by an exponent, you subtract. So we can say, hey, that's negative 14 minus negative 4, or in other words, plus 4. So I would get 1 times 10 to the negative 10th. So that is my hydroxide ion concentration. Now here's what you're going to start to look for and start to see is that this number up here, if these are ones, now this changes if these aren't ones, but if these are ones, this number here is a 4, this is a 10, okay, that equals 14. Okay, when we did the hydrogen up here, 7, 7, 14. They always tend to equal 14. So you can kind of figure it out as long as they're ones. If they're not ones, you'll need to use a calculator to calculate it out. But if they are, you can do that, a little bit of easy math. All right, so let's do this example. What would be the hydrogen ion concentration for a grapefruit found to have a hydroxide ion concentration of 1.26 times 10 to the negative 11th? Okay, and then is this solution acidic, basic, or neutral? So remember, Kw equals hydrogen times hydroxide. So really, this is kind of the big thing that we've learned so far. And remember this formula, and it's a good start here. So we always know that this is 1 times 10 to the negative 14th. Kw is always that, so just remember it. H plus we're trying to figure out, and we have 1.26 times 10 to the negative 11th in terms of a concentration there. So I need to divide both sides by 1.26 times 10 to the negative 11th. Now, since this is not a 1, it's not just 1, I can't just do the easy subtract and stuff. So I'm going to take 1 times 10 to the negative 14th. Remember to put it in as an exponent. 1 EE, negative 14, divided by 1.26 times 10, or EE in mine, negative 11. And I get, on a calculator, it comes out to be 0.0007936, which if I wanted to convert that to exponent, I move my decimal there, so it would be 7.936 times 10 to the negative 4. Okay? So, the question is the solution acidic, basic, or neutral? So remember, if your hydrogen concentration is greater than 1 times 10 to the negative 7th. Now remember, we're talking about negative exponents, so the 4, negative 4, that's a bigger number than 1 times 10 to the negative 7th. So this number is bigger than that, therefore this is an acid. Okay? And there you have it. That's the end of the first part. Next part, we'll talk about the pH, and that gets to be much simpler to work with because pH become usually whole numbers, much easier to work with than those exponents.